Hello everyone. Today we're looking at two more types of congruence. Side-side-side congruence, also known as SSS, and side-angle-side, also known as SAS congruence. So let's start off with the fundamentals. Side-side-side congruence occurs if three sides of one triangle are congruent to three sides of another triangle, then those triangles must be congruent. So for instance, if side AB is congruent to side DE, side BC is congruent to side EF, and side AC is congruent to side DF, then triangle ABC must be congruent to triangle DEF, as noted to the right. We see that AB has the same marking as ED, BC, same marking as EF, AC, same marking as DF. All three sides are congruent, therefore the angles and the triangles must be congruent. Let's see. The angle formed by two adjacent sides of a polygon, well, this is what is known as our included angle. Example, in angle ABC, we have an included angle of B between sides AB and side CB. That is to say that this angle B is included between AB and CB. Any two angles formed using the same side lengths and included angle measure will be congruent. This therefore illustrates the following postulate, what is known as side-angle-side, or SAS congruence. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles must be congruent. That is to say that if side AB is congruent to side DE and angle B is congruent to angle E, and side BC is congruent to side EF, then triangle ABC must be congruent to triangle DEF. We take a look at our figures. Well, here's our AB, the same congruency mark as DE. Here's our angle B with the same congruency mark as angle E. Here's our side BC with the same congruency mark as side EF, meaning that triangle ABC is congruent to triangle DEF as per the side-angle-side congruence postulate, or the SAS congruence postulate. All right, so let's take a look at some practice problems on this. Now, to make things clear, folks, for each pair, we're going to tell which postulates, if any, make the triangles congruent. If the triangles cannot be proven congruent, we're going to write cannot be determined. Our first thing we should always do is determine if the triangles are congruent, naming whatever method we use. If the triangles aren't congruent, we write can't be determined, and we do not name any congruent triangles, okay? The order in which we name them does not matter. So, for this first one, triangle FGE. Now let's make that a little brighter. FGE. So this triangle right here, we want to figure out, is it congruent to the other triangle? Well, see here that we've got a mark here and a mark there. So FG is congruent to GH. 3 slashes there, 3 slashes there. FE is congruent to HE because of our 3 slashes. And while this EG doesn't have any slash marks on it, this EG is in both triangles. Therefore, it's the same length. So we've got 3 congruent sides. So we can then say that triangle FGE is going to be congruent to triangle HGE by our side, side, side congruency. In number 2, we have our triangle ABC, triangle ABC, and we want to figure out if it's congruent to anything. Now, over here, we've got a congruent side here mark, and that mark there. We've got this angle congruent to that one, but this is a cannot be determined situation, because even though they share this side, this angle is not an included angle. So, is it congruent? Well, can't determine. We don't have 3 sides that are congruent. We don't have 2 sides and the included angle between them. Therefore, we cannot determine if this is actually congruent to another triangle. So we move on. Number 3, we're looking at triangle XYZ. Want to identify its congruency here. And while our triangle for XYZ does have a side, an angle, and a side marked, if we look over to triangle PRQ, we have is a side, side, and an angle marked. Side, side, angle. We don't have the same sort of relationship of congruency. As such, we cannot determine. Because this does not fit with either our side angle side or our side, side, side. So we move on to number 4. And here we've got a few things. We've got triangle, where is that J? JKL, and we've got our side, side. While it doesn't show a marking for our angles, if you remember back in Unit 1, we had that definition of the vertical angles. It is to say that 2 angles on opposite side of a vertex, on opposite side of an intersection, are going to be congruent. Well, line JN intersects with line LM at K, which means by our vertical angle definition, that angle is congruent to that angle. So what we have here is a side angle side relationship between triangle JKL and triangle NKM. All right, last bit here. We're going to state what additional information is required in order to know that the triangles are congruent for the reason given. So for instance, number 1, side, side, side. Well, we know that RQ is congruent to SD. We can also assume that because QS is shared by both ends, that it must be congruent to itself. So what we really need to know is whether or not segment RS is congruent to segment DQ. Because if RS is congruent to DQ, then we're good. If it's not, then we're not. So again, folks, all we're doing here is figuring out the additional information that is required. Okay? Side angle side for number 2. Well, we know that UV is congruent to VK because of these marks. We know by vertical angles that this angle here is congruent to that angle there. So the last thing we would need for side angle side is to know if segment VW is congruent to segment VM. Let's say that VW, VM, because that will allow us to have our side angle side relationship. And that, folks, is the extent of today's notes. For all juniors taking the PSAT tomorrow, good luck. Everyone else, there'll be a tutoring Zoom, and we'll reconvene on Friday for the second part of this lesson and the assignment.